So last lesson we talked about the commutative and associative properties. So we're going to talk about the last of the big three, let's call them, is the distributive property. And you'll see throughout this course and throughout many of your other math courses that the distributive property is really a big deal. So let's talk about this, and let's start basic. So instead of starting with sort of the algebra portion of the distributive property, let's go to something you're familiar with. So exercise 1 says, consider the product of 4 times 15. Evaluate using the standard algorithm. So your standard multiplication says 15 times 4. Okay? And we would multiply the 4 by the 5, got 20, got 2 extra 10s, 4 times 1, 4 plus 2, so we know that it's 60. Part B says, represent the equivalent product 4 times 10 plus 5. So notice that that 10 plus 5 is just 15 in disguise, that one right there. Okay? As a repeated addition of 10 and 5. So what do we mean by that? We need 4 10 plus 5s. So we have, there's 1, there's 2, there's 3, and 4. So let's add this up a different way. So if we think about it, adding 10s, 10, 20, 30, 40, and then 5, 10, 15, 20. What's 40 plus 20? 60. Okay, and you can actually see where this is going. This is just a distributive property again. So if we look up here, it's 4 times 10, 40. 4 times 5, 20. 40 plus 20 is 60. Kind of cool how that works with the distributive property. So exercise 1, it says, shows the important property of being able to apply a multiplication to all parts of the sum. So what does the distributive property look like in symbolic form, meaning just with letters? Right there. Okay. A times the quantity of B plus C is equal to A times B plus A times C. So exercise 2, evaluate each product by using the distributive property to make it easier. It says, on exercise B, express 18 as a subtraction. And it says, don't use a calculator. So if I had to think about 7 times 23, I could use that standard algorithm that you know, but it says to use the distributive property. So how could I represent 23 in a different way? Well, 23, isn't that just 20 plus 3? So then using that distributive property, I'd end up with 7 times 20, which is 140. And then 7 times 3, which is 21. And we can add that up, 161. So just another way of looking at it, involving properties. So 9 times 18, and they're saying represent 18 as a subtraction. So 9 times, I could say 20 minus 2. That's 18. Now notice, you might say to yourself, well, where are you just coming up with randomly 20 minus 2, or back in part A, 20 plus 3? Thinking about your tens, okay, your closest groups of 10, that's how I always think about things. 9 times 20, okay, we should be able to get that one, guys, 180, and then 9 times negative 2, minus 18, so 180 minus 18, 162. Again, different way of looking at it as opposed to the standard algorithm. So it says the distributive property can be used twice in order to multiply 2 digits. For example, find the product of 12 times 28 by evaluating 10 plus 2, which is 12, and 20 plus 8. Show each step in your calculation. So if I'm going to look at that, I'm going to rewrite. So 10 plus 2, 20 plus 8. Distributive property twice. What do you mean by that? So 10 times 20, 200. 10 times 8, 80. And then 2 times 20, 40. All of these should be pretty quick in your head. 2 times 8, 16. Okay? And then 20 plus 80 plus 40 plus 16, you should be able to come up with 336. So multiplying that, not using the standard algorithm, but using the distributive property to be able to come up with the product. Go ahead to the page. So now let's take it to that algebra level and express the products as binomials. So binomial means you've got two terms that prefix bi. And so what do? 5 times 2x, 10x. 5 times 3 plus 15. We can't, sorry about the way that 5 looks, we can't combine those because they're not like terms. There's our binomial, there's our expression, there's our product. Okay, go ahead and pause it and try B, C, and D on your own, and then start it back up to check it. Okay, I hope you checked your work to B, C, and D. The only thing you got to be careful of, in letter C, when you multiply x times x, you get x squared. Okay, it's the only thing that's new there. So it says one common mistake students make is not realizing that the distributive property works for division as well as multiplication. So what does that look like? So if I had b plus c all divided by a, that's equal to b divided by a plus c divided by a. So let's see what that looks like with these. So if we're going to use a distributive property with this division, 8x divided by 2 plus 4 divided by 2. Now simplify those two fractions. So we end up with 4x plus 2. Okay, pause it and try B, C, and D. Okay, go ahead and check your work. On C and D, dealing with those fractions, just simplifying those fractions. So that 2x divided by 4 is 1/2 x. And then in D, simplifying those two fractions, we end up with negative 3/4 x plus 3/2. Go ahead and let's go to the next lesson on equivalent expressions. Okay, equivalent expressions. So, equivalent expressions, two or more algebraic expressions are equivalent, okay, that term highlighted for us, equivalent, if they have the same value for every value of the substitution variable or variables. In other words, no matter what you stick in for x or y or z, the two expressions come out equal. So we've got this chart. It says, consider the three expressions below, substituting in the values of x given, determine which two expressions are equivalent. And we're going to show our calculations. So that first expression, I've got 5 times the quantity of x minus 3, and the chart's telling us to substitute 7 in. So 5 times 7 minus 3. Got some order of operations we could do there. 7 minus 3 is 4. 4 times 5 is 20. Or if you want to do the distributive property that we just got done with, that's going to get you to the same answer as well. And let's just go down that column and let's do the same thing with 0. So 5 times 0 minus 3, that's going to give us a negative 15. And then with x being 1, 1 minus 3, 5 times negative 2, which gives me a negative 10. Going over to this next expression, 5x minus 3. But we're still doing that same thing. We're substituting 7 in. Okay, first, 35 minus 3, that's going to give us 32. 5 times 0 minus 3. That's going to produce a negative 3. And 5 times 1 minus 3. And that's going to give us 2. And then in that last column, we've got 5x minus 15 as our expression. 5 times 7 minus 15. So 35 minus 15, 20. 5 times 0 minus 15. The stylus doesn't want to make a minus sign there. Sorry about that. I don't know what was happening. And then 5 times 1 minus 15. There we go. And we end up with, I got to backtrack here, negative 10. And this one gives me a negative 15. So looking at which two columns produce the same exact answer. So I've got column 1 here in the red. I've got 20, negative 15, negative 10. And then this third column, I got the same answers, 20, negative 15, negative 10. Gee, how are those two expressions related to each other? 5 times the quantity of x minus 3 and 5x minus 15. What property is being shown there? We've got the distributive property going on. Okay. That's why those two columns are equivalent expressions. Okay. So I just answered question number 2, didn't even realize it, and the distributive property. Okay, exercise 3. Which of the following expressions is equivalent to 5 times the quantity of 2x plus 1 minus 4? Show your work to justify your response. Test at least one value of x to check your answer. So I've got the expression. I'm going to use the distributive property. And I know it's 10x plus 5 minus 4. Those are my like terms. 10x plus 1. So it looks like that's my answer. And it says test at least one x value to check. So I'm going to go with the easiest value to work with, 0. And I'm going to put it into our given expression, and then I'm going to put it into what we came up with after we simplified. So 5 times 2 times 0 plus 1 minus 4. I apologize for that. I'm running out of space here. So some order of operations. 2 times 0 and 0 plus 1. So I've got 1 times 5 is 5. 5 minus 4. I know to be 1. So let's see. Does it happen the same thing with our answer down here? Plug in 0. 10 times 0 plus 1. Certainly shows that those two expressions are equivalent. Go ahead, flip the page. Okay, which of the following expressions is equivalent to, wow, okay, getting a little bit more complicated. Again, show your work. Think about your order of operations. Check your answer by substituting a value of x. So with that expression, I certainly would start with the numerator, and I would start with my distributive property on top. I'm just going to kind of move my work over, and so it gives me a little bit more space. 12x plus 4 minus 2 in the numerator, and that's all divided by 2, but don't forget that minus 5 there. Again, I would stick with simplifying what's in that numerator, and I'm left with 12x plus 2 all divided by 2. Don't forget, again, that minus 5 there. But let's use the distributive property with that division, okay, like we did in our last lesson. So I've got 12x divided by 2, which is 6x. 2 divided by 2 is plus 1. And then I still got that minus 5 hanging out on the end there. Combine those like terms. 6x minus 4. Okay, so now let's see, is that true? 6x minus 4. So again, let's go back and use the simplest x value we can, which is 0. When I plug it into my original expression, 4 times 3 times 0 plus 1 minus 2 divided by all divided by 2, and then minus 5. So inside the parentheses there, 3 times 0 plus 1 is 1. 1 times 4 is 4. I'm doing a lot in my head here. Okay. So I've got 4 minus 2 in the numerator, all divided by 2, minus 5. So 4 minus 2 is 2. 2 divided by 2 is 1. 1 minus 5, negative 4, is that original expression. And then let's check our answer. Use that same value. X is 0. If I did 6 times 0 minus 4, look at that. That gives me a minus 4 as well. Okay, so that just checked. That proved that, yes, we did do all of our calculations and simplifying correct. And that ends up being choice number 4. Okay, we're almost done. Which of the following expressions is equivalent to 10x plus 15? Explain how you made your choice in the space provided. Well, looking at it, it's a multiple choice. So I always tell kids, when you're stuck, you certainly can play the multiple choice game and test all the choices and see which one would be equivalent to that 10x plus 15. But let's think about sort of undoing the distributive property on that. I've got 10x plus 15. So what was multiplied? What was outside the parentheses that was multiplied by some binomial to give us 10x plus 15? So I think to myself, I'm like, okay, what does 10x and 15 share in common? They share a common factor of 5. So that's what could be outside the parentheses. That's one possibility. And then I'd say to myself, okay, if I were to do the distributive property here, 5 times what value is going to give me 2x? Or excuse me, 10x. It's 2x. 5 times 2x gives you that 10x. And then I'd say to myself, okay, well, I know it's plus. 5 times what value is going to give you 15? And that's 3. So now we just did the reverse of the distributive property. Okay. Reverse of distributive property. I abbreviate. And reverse of the distributive property actually has a name for it, and that's called factoring. Okay? So factoring some expressions. Factoring is the process of writing an equivalent expression. It's purely the product of other expressions. This is going to be huge this year. You're going to do lots of factoring later on. So reversing that distributive property is going to be huge. So when I take a look at A, I'd say, okay, well, what do they share in common? What factor does A share in common? We've got 6x plus 21. They share a common factor of 3. So 3 times what gives you 6x? 2x. 3 times what gives you 21? 7. Done. B, I might say my common factor is negative 2. And that's going to be an x. And, oh, be careful. Negative 2 times what? It's going to give you positive 10. It's going to be a negative 5. And then this last one, what do they share in common? They share 14 in common, x plus 1.